Working with an electrochemical cell depicted by the following chemical equation. What is the function of the U-shaped tube B? A. To allow NO3- into the left and K plus to the right. B. To allow NO3- into the right and K plus to the left. C. To allow electrons to flow through the tube from right to left. And D. To allow electrons to flow through the tube from left to right. This is a difficulty 4 question. Okay, let's just redraw some of the general concept of what we have. I'm going to scroll down here, and here we have zinc. Okay, we have our zinc 2 plus, and we're going to say this is our zinc, and over here we have our copper. Okay, we have our copper 2 plus. Okay, and what kind of solution are these in? Well, here we have our solution, and in here the whole concept of what is happening. By the way, the solution is NO3 minus, NO3 minus, and these are both connected in a typical electrochemical cell by a wire that's hooked up to this voltmeter here. Okay, so essentially what's going to happen? Well, right away we know that copper is going to be more reactive, right? So at least to the electrons. The electrons are going to be more attracted to the copper. So here comes the electrons. They're going to go through here, and they're going to go towards the copper. That we already know is going to happen either way, regardless of if we had this tube here or not. But the fact of the matter is that would only occur for just a couple of seconds before the reaction would no longer continue. Why would it no longer continue? Well, the zinc over here, this zinc metal that we have that's a solid, is going to lose electrons, so it's going to become a zinc 2 plus ion. And the zinc 2 plus ion is going to partner with a nitrate. Well, no big deal there, but then when we look on this side, we have Cu2 plus that is accepting electrons, and the copper is going to start forming on this metal here. And when the copper starts forming on this metal here, you're going to have more nitrate here, and here you're going to have less nitrate. So it's not going to be balanced. So it might occur for a second, but after that it's no longer going to occur. The reaction won't. So then we're going to put this tube in here like we see in our diagram in your typical electrochemical cell. In this case, I believe it was KNO3 was the solution that we had. Yeah, it was KNO3. So in here we have KNO3 in the salt bridge. That's what they call this, the salt bridge. And essentially what this does is this keeps it all in equilibrium, so the reaction can continue to happen. So on this side, logically, if we think about it, we have a zinc metal, right, that is being displaced, right? It's leaving this metal and it's coming into here, so we have more zinc 2 plus ions because they're losing the electrons. The electrons are going that way. And when the electrons leave, we're left with the ion. So here, we're actually going to have these two guys partnering. So we're going to need more NO3 minus to counteract the positive charge from the zinc. So on this side, we're going to have NO3 minus traveling, which means on this side, we're going to have K plus. If you think about it logically, the Cu2 plus is moving onto this metal, right? Because these electrons are coming. So for the electrons to stay here, the Cu2 plus ions are going to come out of the water. They're going to come out of the water, and they're going to go on to here and merge with the electron. And you're going to start to get a copper solid forming on here. In the meantime, you're going to have an increase in nitrate. So when this when this potassium, the K plus comes through here, it's going to partner with that nitrate, right? And then this is going to become KNO3, so that this reaction can continue to happen while the copper is being placed onto the surface. So let's look at some of the answers. What can we rule out? D, to allow electrons to flow through the tube from left to right. Well, we already know that the function of the U-shaped tube, is not to allow electrons to flow. Yes, electrons will flow in this case from left to right, but that's not the function of the U-shaped tube. That will happen spontaneously. To allow electrons to flow from the tube from right to left, we know that's not something that's going to be happening in this reaction. To allow NO3 minus into the right and K plus to the left. Okay, well let's think about it again. NO3 minus into the right, this one says. So this is saying that we are going to get the negative ion, or the anion, the NO3 minus, in this direction. Okay, sorry about that, that was my phone. And we know that's not going to happen because here, remember, we're going to have an increase in NO3 minus. So we don't want, we're not going to need any more NO3 minus to go down this path. This is the area where we're losing NO3 minus because they're partnering with zinc. So we're going to have less of the anion here. So we know this answer is incorrect just by seeing that. Here, to allow NO3 minus to the left, which makes sense because we're losing, we're gaining more zinc 2 plus in the solution, and on the right, the K plus is going to be able to counterbalance the loss of the copper 2 plus ion for the nitrate. So we know that the answer in this case, it must be A.